This is Chapter 6, Part 4, dealing with nested loops. Basically, a nested loop, if you recall from 105, your Program Design Development class, a nested loop just means you have a loop inside of a loop. Now, whenever you have this occurrence, you always need to perform the outside loop to determine whether or not you are going to be able to enter in and process the secondary loop, the inner loop. However, once you start processing the inner loop, you will continue processing that loop until the condition is met, then fall back outside to the outside loop. So, outside loop just to make sure you can get to the inner, repeat the inner over and over again until a condition is met, then fall back to the outer loop. You will continue doing both inner and outer loop multiple times until both the inner loop condition is met and the outer loop condition is met. As always, I have pulled up the code for Divide Evenly 2, which is basically just the program that we previously created, Divide Evenly, with an extra loop added to it. So just very quickly to run back through that, there is a constant limit with an assigned value of 100. You've got an integer var. Now a new addition is an integer number. We do still have our prompt here, our system.out.print, which just simply prints that 100 is evenly divided by, and then we start the process of counting. Our outer loop is for number equals 1, number less than or equal to limit, plus plus number. Okay, remember that is just the header of our for loop, our definite loop. We are going to start with setting number to 1. We are going to process the value, this loop, as long as whatever number is less than or equal to limit. So that's when we stop. And every time through the loop we increment number by 1. That is our outer loop. Our inner loop is, we are going to have another header there that says whatever number is evenly divisible by, with a for loop that var is equal to 1. As long as var is less than or equal to number, we're going to continue the loop, and every time through we're going to increment by 1. Now again, remember the percent sign is modular division, so if number, modular division, var, compared to 0, so we're checking to see if there's any remainders. If there is not a remainder, if it is a whole number, then we're going to simply print whatever that number may be with a space. We're going to offer up an extra line, just a print line there. Okay, so that'll get that information. Now, once we have entered into this inner loop and we have processed through, and this is basically divide evenly, the last program we just did, we are going to fall back through to the outer loop to check the value of number. Okay, now basically what we're going to do is we're going to count from 1 to 100 on the outer loop, and every time we go through we're going to see if those numbers are divisible by var, and then we'll see what we come up with. All right, so let's compile it. I get a good clean compile. We're going to run. Now my input output here does take up a little bit of information, a little bit of space, sorry. So I'm going to kind of expand that window a little bit so that we can just analyze what we have. All right. You will notice that we do have 1 is evenly divisible by 1, is evenly divisible by 1, so there really should have been a print line right there. And then it begins counting. 2, 3, 4, 5, 6, 7, 8, so forth, all the way down to 100 is evenly divisible by. All right, so that is the outer loop. That is the for number equals 1, number greater than or less than or equal to limit, plus plus 1. All right, that's where those lines are coming from. The is evenly divisible by, and then that second group of numbers is your inner loop for var equals 1, var less than equal to number plus plus var. So the outer loop is responsible for counting 1, 2, 3, 4, 5, 6, 7, so forth to 100. The inner loop is responsible for doing the division by whatever number we may be working on. And you'll notice as you increase, 4 is evenly divisible by 1, 2, and 4. 5 is evenly divisible by 1 and 5. So it just continues to increase as you go, working both inner and outer loops. That is the conclusion of part 4.